expert is Dr. Enrico Venturini, comes from Italy, to speak about textiles, the trends of textiles in building and living. Enrico Venturini is a senior research and project manager at Next Technology Tecnotessile. He has a university degree in economics and business administration and textile technician diploma. After taking a textile high school diploma, he graduated in economics at the University of Florence. He then specialized in industrial quality control and developed significant experience in this field within textile company. Since 1996, he has been holding the position of project manager at Next Technology Tecnotessile for research projects, and he has also a qualified trainer in the textile sector. He's participated in several European projects. Please, Enrico.
Thank you. Thank you, Paolo, for this very nice introduction, and good morning, everybody, ladies and gentlemen. Today, I will try to focus on the topic of textile for building and living, which is another very important topic in terms of technical textile applications. As you have maybe noticed, my background is a little bit different from the speakers before, so I'm not so much academic, so my approach will be a little bit more practical, if you want, because as Paolo said, I work for the research center, and we are trying to develop technologies that can be really find applications in daily routines with companies, industries, in particular SMEs. Now, going to the topic of my presentation, of course, there are big, wide possibilities in terms of possible application of technical textiles in the building sector. And the applications that we have seen so far have improved a lot the quality of construction that are performed today, because, of course, textiles are very flexible and are very light if you compare them to other materials that are regularly used into the construction sector. And of course, textile can provide lightness, a high resistance, a big resilience. So they are very good also for providing functionalities. Creep resistance, resistance to chemical and degradation of atmospheric agents, and so on. So what we have seen today is that textile instead of concrete, it's not anymore a slogan, it's a fact. And this has been taken from a scientific journal of 2011. They were saying so, and I think it is true, because if you can see, as you can see from the pictures, textiles are used in many applications today in construction sectors. So buildings, dams, bridges, tunnels, and roads are some of the building items where textiles find application. But in terms of interiors also, of course, we think the first thing we think is the interiors for couch coverings, curtains, this kind of things, carpets, but also there is a huge sector in terms of contracts. So public spaces, hotels, theaters, conference halls, etc., are very relevant in terms of utilization of textile, and also as in societal aspects like hospitals, medical centers, and schools, where everybody spends, offices, workplaces, where everybody spends a big amount of our lifetime during the day and during our life. We are surrounded from textiles, and textiles could be really could have a leading role in improving the living conditions into these environments. Normally, when we refer to textile applied to building sector, we talk about build tech. Buildtech can provide, as you can see here, I have listed a little bit the acoustic and thermal insulation. Okay, the pointer is not working very well. The protection against atmospheric agents like sun, wind, fire, water, against UV rays, electromagnetic radiations. They are combined with electroluminescent and LED material for energy saving, energy production. And also we use textile to reinforce concrete. So we have many applications in terms of materials, in terms of composites that are used. We have many different kinds of materials, of course, glass. These are technical fibers, okay? So high tenacity fibers, glass, aramidic fibers, carbon, cross-link with resins, but also natural fibers. As have been said before, they start to have a very important role into the improvement of building, and also synthetic fibers. Because if we think about the trends for the future, more or less we can repeat what has been said before from my colleagues. So sustainability, for instance, is one of the key trends. And so this is why also natural fiber and also the recovery of waste is important in building sector. Many applications nowadays are realized through the recovery of waste from textile sector, for instance, because textile process for apparel produce a big amount of waste. We have seen carbon that is producing a big amount of waste during the processing. All these waste can be recovered and not disposed into the environment and utilized for realizing composites or other materials that are used into the environment. And I think this afternoon you will have the chance to see some examples, very interesting examples of how the recovery of this waste can be used in the building and also in other sectors. The state of the art. Now I'm going to go through very quickly what are the materials and the technologies that are applied today to see how textiles can help to overcome some of the difficulties that normally used technologies and materials face in the building sector. So we have semi-rigid fiber-based insulators like rock wool. Rock wool is a material that is very much used into the building, but it's very good to some extent, of course, because of its tenacity and the insulation power, but it presents also some issues like the health protection of people, because rock wool can produce microfibers, as you know, that can affect the respiratory apparatus of people living in this environment. Then we have polyurethane and expanded polystyrene. Also, these semi-rigid synthetic and natural low-density insulators have a problem because they have high flammability. Over being difficult to overlap with other materials, in case of fire, here you can see an example of different phases of a fire occurring in a building where the facades were covered with this material, in particular expanded polyester. They produce like a multiplier effect, and so the propagation of the fire is very fast, is faster than what it should be. Bituminous membranes, so we have here some layers of textile materials, but this application is very used in the case of roofs, but there is a risk of water stagnation, and we can have, this can cause microperforation of roof components. Last example I'm going to show you is this multi-layer material which has been transferred from the aerospace sector because it is used in the construction of some components of the aircrafts or also for space shuttles. And this is a multi-layer composed of films, fibers, and thin foams, including polyester and aluminum, as you can see here. So it is very light, it is very resistant, it has high tenacity, but it's not transparent. It cannot be combined with plaster, and it has no compressive strength. So these are some of the issues that can be tackled through the application of textiles, okay? So tomorrow's building will be more and more inclusive of textile, and in particular technical textile. Here I have used a quite evocative image because here you see like it can be a store or an office where we have no more walls, or at least we have different kind of walls, because both the ceiling cover and the walls are replaced by textiles. Why new materials? Because new materials can provide, first of all, functionalities, and traditional materials are not able to do this, so that customer needs can be met, and we can provide extreme customization and also novel applications. As new properties are possible because the manipulation can go up to the atomic scale for diversified function. So standard properties of our technical textiles are tenacity, durability, thermal and acoustic insulation, and of course also aesthetics in some of the cases, like in interiors. What we can add through the novel technologies and novel applications are some functionalities like dirt repellency, self-cleaning, bacteria killer properties, mildew proof, air and water depuration, solvents degradation, anti-static, and many different kinds of shielding from UV rays, radio frequency, sunlight, etc. Okay, so these are some of the possibilities, and we're going to see some examples. Of course, what we're going to see is not exhaustive. There are many possible applications, and we discussed this also yesterday during the working group for textile for building. Sustainability is one trend, but also the application of smart textile is another trend in terms of self-regulation of the components of the building, for instance, of the concrete. So there are many possibilities here, and these new materials can be mainly composed, this is quite consolidated now, by nanotechnology. Nanotechnology, they can provide membranes for acoustic and thermal insulation, energy management, so energy production and energy harvesting, control light transmission, easy cleaning, and decontaminating behavior. Here I have taken from a study realized some years ago, this table where you can see the TRL, the technology readiness level, for different technologies that can be applied through nanomaterials, nanotechnologies in different building applications. And also they can be used in the renovation of buildings. So they can provide self-healing functions, crack repair, reinforcement of critical walls. Also the roping of existing building is another very important topic through membranes, protection against earthquake or hurricanes, and incidents in terms of explosion and protection. Solar and acoustic protection. For instance, this is a project that has been carried out in Germany. So these are internal or external blinds for roofs. The fabric here is combined with the normal material used for the roof, for the cover of the house, and it can adapt in terms of thermal permeability. So this can help to reduce the cost of heating or air conditioning depending on the season, because the heat coming from outside can be filtered and adjusted. So this is another example. I also have here some samples if you want to see. Yes, I know I'm already late, but I have many examples. This is fiberglass fabric that is used, it's produced by an Italian SMEs, and it's used for the acoustic and the thermal regulation of the interior environment of the building. This is another interesting material because it's a 3D textile that creates an inner tube. So this can be introduced into the normal components like walls or roofs, and can create this sort of inner tube for the insulation. So it's very droppable and very resistant. Sorry, I have to run. This you will see in the afternoon. So this is an anti-seismic solution for building, but you will see this in the afternoon. And in terms of nanoparticles, I'm going through this. We have a patent for the photocatalytic textile. This is another very interesting function because it can provide health, comfort, in public spaces. So with the photocatalysis, the polluting gases are transformed into different gases that are not harmful for the health of the people. So one application is the synthetic grass. The grass synthetic can be treated with here I have a video, we don't have time to see it. The basalt fabrics, they can replace the rock wool because they don't have the same type of problem of the rock wool. And so we can create composite material with basalt to provide the thermal screens or barriers to fire or filtration, etc. Carbon fabrics are also very much used into building sector because of their light. They're 2/3 lighter than steel. They're stiff, so 2 times stiffer than steel and 5 times stronger than steel. So you see they are very widely applied at concrete, sorry, the word didn't come to my mind. This is photochromic and thermochromic fibers. They change color according to some other parameters like the internal temperature. So if we have a too much high temperature in a room, the walls that are covered with this textile, they can change color. So they're very helpful in terms of safety. The heat shielding fabrics, and also there are fabrics that are able to conduct heat, but we don't have. Optical fibers application are also very interesting in terms of future applications. Nowadays, there are some luxury products using optical fibers in combination with other very fine yarns like silk wool and linen. And here you can see some examples, for instance, curtains or table covers. But there are also technical application of optical fibers that could help a lot. And here, if you are interested, and I'm going to my conclusion, we have developed a few days ago, so they're still very, very primitive, some samples of a new material which is only composed by fibers. There are different kind of fibers. There is no glue, no resin, no silicone, nothing. Through a thermal process, we can produce many different ideas, applications, and they can be used for interior components. You can combine different kind of fibers. For instance, now you cannot see from there, but this is done with the same process. It's only fibers, and these fibers are combined with waste coming from the food sector. If you would like to see from close distance later, you can come and talk to me, and you can have fun trying to guess what kind of food waste is included into this. So there are infinite possibilities for application of textile waste, as I said before, into building sector. Thank you very much for listening to me.
Thank you. Sorry.
No, it's okay. I'm finished. Thank you very much.
Thank you, Enrico. Paul.
Yes.